Okay, for experiment 3, they want you to put a red and a blue line in like this, and then they want you to get the mirror, and then they want you to get the lines going like this. So the red line reflects and the blue line reflects, and then you just draw the dots in with the red, and you draw the dots in with the blue, and then you draw it out. So I just get my ruler out, and there you go. Not quite sure what the point of this is, to be honest. And so there you go. All right. And so then they come up with these questions. Is the left beam red or blue? What happens to the image in the reflected plane? And then they start going on about lateral inversion of reflection, if you look at the right-hand side. And this one's called lateral versus vertical inversion. And the reason I do experiments is to get away from English words. And if you do a little bit of research on lateral inversion, they're saying that that's just a perception that it's laterally inverted. And basically what's in the mirror is what your brain perceives to be an image. So I think they're kind of doing exactly what I don't want to do, which is put English words in there to confuse you and not really understand what's going on. But before I get to that and explain this lab properly, the other thing I want you to do is to do this LR. So here's a picture of me doing the LR, and when I turn it around, which is me inverting it, funny enough, the mirror shows me what I did, which was laterally inverting it. And so I'm thinking, this is just dodgy, this word. Why are we introducing this word for? I've never needed this word. And I put it on a piece of glass, only to realize later that they actually ask you to do that as well. And I'm thinking, look, if I do it on a piece of glass and don't turn it around, it's LR and I can read it perfectly in the mirror just as I can right there. All right. And then if I turn it around and invert it, yeah, funny enough, the paper's inverted and so's the letter, but it hasn't changed. I still see it in the correct way, and the mirror is correctly showing me what I'm presenting to it. So I am more in favor of this. It's not really lateral inversion. I think some people are calling it up and down inversion. All of that is qualitative. It's English, which is not going to get you to an understanding of science. So if you want to understand science, you've got to see past the words. I know, unfortunately, you need the words to write down on a paper, English on an exam. But to understand science, you've got to think how the universe thinks. And that is not necessarily going to be put down on paper, but we can do it here. Sometimes the thinking is difficult, but we can do it with the ray diagrams. And so another major reason why I'm doing physics videos is because I feel like they've lost all their understanding because they've removed the ray diagrams from year 11, 12 physics, and we don't do enough of it in junior science. So I'm trying to fill the gaps here to get you good at science. So I've done this diagram here because it wasn't focusing very well when I was drawing it, so I just did one on the screen. So what you can see is the major issue here is that your eye perceives light as traveling in a straight line. And so we're going to get into, we're always going to end up touching on the biology here because it's about light, and the way that you understand light is not that scientific, actually. Your brain thinks everything's traveling in a straight line. So when you look in the mirror, what you're seeing is a line that has reflected off this real arrow, and your brain's thinking it's just all in a straight line, and so it perceives that it's projected into the mirror, and that's where it's coming from. And so that is why you see an object that's behind a metal wall, basically, and your brain thinks that something actually exists over there, because if you look carefully, the light has come and reflected angle of incidence equals angle of reflection. You can see all these angles all match up. Didn't draw the normal in because it'd be too messy. And that's why you can see what you can see. Okay, and so there's no inversions or whatever. You need to draw a ray diagram to understand why your brain is seeing something as it sees it. And that's how the universe is working. That's how the photons are traveling, and that's how your brain is understanding it. So always best to do measurements and draw what is actually happening, and forget about the English terms for that, because that will just confuse you and it doesn't actually explain anything. And then I found out later that they've actually done the glass thing. They've asked you to do it and do some predictions, but no real understanding. And then get a mirror out and start doing silly things. So there you go. There's me doing the mirror, trying to work out what my best side is. Do you think it's that one? I don't know. My family didn't think this was funny. I thought this was funny.